Okay, this lab is fairly simple and fairly brief. Okay, you're going to start off with 2 dice.
Can we draw that?
Yes, draw that. 2 dice. Okay, and you are going to have these 2 dice do opposite motions. One is going to free fall, and the other one is going to be a projectile. Okay? So, free fall, projectile. Now, we've discussed free fall. What is free fall?
Falling, just no gravity or
Yes? Okay, no air resistance. Falling without air resistance. Now, we have air in this classroom, but the fortunate thing is air resistance usually doesn't make a big noticeable difference until you're at really high speeds. So this is going to be all relatively low speed motion, so it makes very little difference. So it's pretty darn close to free fall. Okay? Projectiles. What's a projectile? Alright, when something is thrown or shot. Okay? So we want to free fall and projectile 2 different dice at the exact same time. Okay? Which is not easy to accomplish. So, you have to take 2 dice. Okay? You have to hold them up in the air, okay, so that your hand is above the dice. Okay? You're going to flick one of the dice so it shoots out horizontally. And the moment you flick one of them, they'll both fall. And so they'll start falling at the exact same moment. Does that kind of make sense? So the one that gets flicked forward is going to be our projectile, and the other one that doesn't get flicked forward is going to fall straight down. That's going to be our free fall. Okay? It takes a little bit of practice to get it right, so you got to try and try again. I recommend, if you have a cell phone with a slow motion camera, videotape it. It's really cool. It's really cool to watch. Okay? So if you have the slow motion camera on your cell phone, video record it on the slow-mo camera so you can watch it. If you don't have the slow-mo camera, you use your ears. Well, either way, I still want you to use your ears. Your ears are more accurate than your eyes. You can hear which of the 2 hits the ground first before you can see it. All right? Your eyes won't be able to tell you which one hit the ground first. But your ears will, because you're going to either hear like that, or like that, or like that. Does that make sense? You're going to hear which one hits the ground first. Much better than you're going to be able to see it. Okay? So, that's the lab. It's really not that hard. You can pick your own partner. First thing I want you to do, draw. What does it look like, the paths that those 2 travel? So the one that free falls, what does it look like when it falls? Straight down. Just got and at some point just like draw a line, that's the ground. Okay? Fall straight down. What does it look like for the projectile? Does it go out like this?
No, vertical.
no. Like an arc.
All right, I like it. Arc.
So it depends on how hard you get it going.
All right, if I hit it even harder, it would come out like that, right? And even harder, but it would still have a curve to it, right? Okay. That is the shape of projectile motion. All right, so now the question I have, what were your observations? What did you observe? Okay, so these both, the free fall goes straight down, the projectile falls over there. Now, what we did, procedural-wise, for this lab, okay, under the conditions, so below, right at number 1. If you create the condition where the projectile must be shot horizontal. Okay? The projectile must be shot horizontal. If you have that condition, then what happens? Which one hits the ground first? So if you're not convinced what you see with your eyes in this recording, at least use your ears. Try and hear which one hits the ground first. You should hear that they hit the ground at the same time because you only hear one sound. In reality, if it works out perfect, they hit the ground at the same time. Okay? So they fall together. And 3, they hit the ground at the same time. Now when I say they fall together, okay, let's put that in the drawing. Let's make that visible, that idea of falling together. So we know as it falls, we've talked about free fall, okay? So free fall, as it falls, the object does what?
It accelerates.
It accelerates as it falls. Okay? And if you look at that picture from before, this is what it looks like when an object accelerates. So, accelerates as it falls. Draw both of them right there. It's like on the first line below. Accelerating means it's going to go even further, so draw them right there. And then it's going to go even further, so give it a bigger space. But make sure the 2 dice are always horizontal. And then it crashes to the ground. Dun, dun, dun. Okay? So with this lab, I wanted you to realize that they do fall at the same time. It actually doesn't really matter how fast it's going forward, it will always fall at the same rate. This also works with a bullet in a gun and a bullet being dropped. Doesn't matter if it's going that fast, okay? Now, when I was in high school, my physics teacher was not able to convince me that this is true, okay? I was like, whatever, the bullet that shot out of the gun goes so far, it falls slower, it doesn't hit the ground at the same time. What makes the dice hit the ground? Gravity, right? We all agree? Now, is gravity affected by how fast you're moving? If I'm running super fast, is there less gravity pulling on me?
There's more. No,
If you're in a super fast car, going really super fast, are you going to weigh any less?
No,
It's still the same, isn't it? Gravity still has the same effect. Doesn't matter how fast you're moving. Does that make sense? So it shouldn't matter how fast that projectile is going horizontally. It still falls at the same rate. Does that make sense?
Yes.
Yes? Okay. So that's really what I wanted to accomplish with the lab, with the short little lab.